Hello everyone, thank you for watching this video. Today we want to solve an integral problem using a new technique, which the following rule. Integral of d of f over square root of 1 minus f square, it's equal to arc sine of f plus c, or also it's equal to minus arc cos of f plus c. But for now, today we will use only arcsin of f plus c. Okay, to apply this rule, we will solve a set of 4 integral problems to show how to use this technique and which kind of exercises of integral we can solve applying this rule. We will begin with listing. We will have here the list of exercises. The first one will be I equal to integral of d of x over 1 over square root of 1 minus x squared. As we can see, for this exercise, the f function here is x, so that we can apply directly our rule for this exercise, and we get the solution written as arc sine of x plus c, where c is the constant of integration. This is the first example, so that we can apply this rule to solve the integral. Okay. Another exercise is the b, where b is I equal to integral of d of x over 1 square root of 1 minus 9 x square root. We know that 9 is equal to 3 power 2. This means that we can rewrite our integral as d of x over 1 square root of 1 minus x, 3 times x, all these square. So the other thing we can observe is we have the differential of 3x is equal to 3 times d of x, so that d of x can be written as 1 over 3 d of 3 times x. This means that where we have d of x in our integral, we will substitute with 1 over 3 times d of 3x. Now we have I equal to 1 over 3 integral of d of 3x over 1 minus 3x squared. Now we can see that our function is 3x, so that applying our rule we get then has the solution written 1 over 3 times arcsin of 3x plus c, which is the constant of integration. If you remember the techniques of derivative of arcsin function, you will see that if this solution we define as a function of f of x, and the first one, the integral, this exercise, we define as the we define 1 over square root of 1 minus 9 x squared as our f, then we can show that the derivative of this function will be equal to 1 over 3 times 1 over square root of minus 3x squared times the derivative of the argument of arcsin, which is 3x derivative. From here we have only 1 over 3 times 3 over 1 over square root of 1 minus 3x square root is the same thing written as 9x squared, and we can simplify 3 by 3 and we get 1 over square root of 1 minus 9x squared. Then this is the solution of our integral problem. Okay, we continue solving the third problem, C, which is integral I equals to integral of d of x over 1 square root of 9 minus x squared. We must write this integral as d of f over 1 square root of 1 minus f squared to apply our rule. Then from here we can see that if we want to have 1 in this part, which is the rule that we have, or the definition of integral we have, then we must take the quotient of 9 by 9, so that to not change our problem, this means that we can write our integral I equal to d of x over 9 1 minus 1 over 9 x squared. Because if you multiply 9 by 1 is 9, and you multiply 9 by 1 over 9 is 1, then this means we are not changing our argument or the function in our square root. From here we know that this can be written as d of x over square root of 9 times square root of 1 minus 1 over 3 x squared. Yeah, because from here you can see 1 over 3 power 2 is 1 over 9, which is this factor that we have here, and x squared is x squared, which is this term that we have in our square root. Square root of 9 is 3, and again this is equal to 1 over 3 square root of d of x over 1 minus 1 over 3 x square. Now we can see that the derivative of 1 over 3x is equal to 1 over 3 d of x, so that we can write d of x has 3 times d of 1 over 3 x has. Then where we have the d of x in our integral here, we will substitute with 3 times d of 1 over 3. And now we have our integral has 1 over 3 times 3 integral times 3 times integral of d of 1 over 3x by over square root of 1 minus 1 over 3x square root. Okay, now we can see that we have f function written as 1 over 3x and d of x is equal to d of 1 over 3x, so that we can apply our integral from here, where the solution for this problem is arcsin of 1 over 3x plus c. We simplify here 3 by 3, so that the integral is arcsin of 1 over 3x plus c. This is our solution. We can apply again the definition of derivative, or the inverse of derivative, or the inverse of integral, which is if you have f of x, d of x equal to f, then the derivative of f must be equal to little f. If you take the derivative of this function, you will get the original function in our integral here. I will show you how to get these solutions. Then we have f of x equal to arcsin of 1 over 3x plus c. The derivative of this function is equal to 1 over 1 square root of 1 minus 1 over 3x squared times the derivative of the argument of the arcsin function, which is 1 over 3x. And from here we have only 1 over 3 times 1 over 1 minus 1 over 3x squared. For now, if you introduce these 3 in square root, you know that this, or you can remember that 3 is the same thing 1 over 9 times 1 over 1 minus 1 over 9x squared. And if you introduce the square root, the 9 in this, or you take the multiplication of this square root, you get 1 over square root of 9 minus 9 over 9x squared, which is equal to 9 over 9 is 1. Then you get 1 over square root of 1 minus 9 minus x square root, which is f, the little f, as we have here. It's okay. We follow to solve the last one exercise, which is the D. D is I equal to cos of x over 1 over square root of 9 minus 4 sine square of x, d of x. Okay, from here we can again put out the factor 9, having 1 over square root of 9 times cos of x d of x over 1 minus 4 over 9 sine square of x. Okay, this means that if you multiply these two squares, you will put the 9 in this, multiply 9 by 1 is 9, 9 times 4 over 9 is 4, as we have in this part. Okay, for now we can rewrite this integral as square root of 9 is 3, 1 over 3 integral of cos of x d of x over 1 minus 2 over 3 sine of x, all these square. All this is square. And again, we know that the derivative of 2 over 3 sine of x is equal to 2 over 3 derivative of sine of x, which is equal to 2 over 3 cos of x d of x. This means that cos of x d of x can be written as cos of x d of x is equal to 3 over 2 d of 2 over 3 sine of x. Now our integral, where we have this cos of x d of x as we have here, we will substitute this expression so that our integral now will be equal to 1 over 3 times 3 over 2 integral of d of 2 over 3 sine of x over 1 minus square root of 1 minus 2 over 3 sine of x square. Okay, we have here in our integral the function of d of x over 1 over square root of 1 minus f squared, as we can see, where our function f is equal to 2 over 3 sine of x. So that we can apply our rule, we simplify 3 by 3, then I is equal to 1 over 2 arc sine of 2 over 3 sine of x plus c, the constant of integration. Then we have this as our solution, the function f of x. Again, we can take the derivative of this function and we will observe that the result f will be the original function in our integral written here. Okay, we can do this to show that it's true. Then the f function is this, and we wanna take the derivative of f. We will have 1 over 2 derivative of arc sine of 2 over 3 sine of x. This is equal to 1 over 2 times 1 over square root of 1 minus 2 over 3 sine of x square times the derivative of the argument of the function arcsin, the argument of arcsin, which is 2 over 3 times sine of x derivative. And from here we have 1 over 2 times 2 over 2 cos of x over 3 square root of 1 minus 4 over 9 sine square of x. From here we simplify 2 by 2, and remember that 3 is 9 square root of 9. Then we multiply 9 by all these functions, and we get cos of x over 9 by 1 is 9 minus 9 by 4 over 9 is 4, then sine square of x, and we have our f function, or the little f function. And now we showed how to use the rule that we have mentioned on the beginning. Where are you? This rule: if you have integral of d of x over square root of 1 minus f squared, then the solution must be written as the arcsin of the function f plus c, the constant of integration. Then we applied this rule for the 4 exercises here, and we saw how to transform a specific integral to the function of our original integral, and we get the solution as written has this using the rule. So thank you for watching this video. See you on the next one. Put like on this and share with your friends. Subscribe in our channel, and thank you for everything. See you on the next video. Bye.